Let's study 9th standard physics chapter 3 from Oswal textbook, numericals belonging to exercise 3C and 3E. Second sum, mass is given, acceleration is given, force is asked. Well, force is equal to ma. You get the answer directly. Be careful about the units. Everything is in SI units, so no problems here. Fourth sum, again very easy. The mass is given and the force is given, acceleration is asked. Same formula. And sixth sum, the force is given and the acceleration is given and mass is asked. Same formula, ma, F is equal to ma. Now the eighth question, a body is at rest, so initial velocity is 0. Always write the data first. Mass is 3 kg. Force of 12 Newton is acting for a time period of 4 seconds. Find the final velocity and the change in momentum. So I've written all the data first. V is equal to U plus AT, but A is not given. So let me find the A first using the formula F is equal to ma. So I'm getting A as 4 meters per second squared. It was not asked, but to find V, I will have to find A first. And then once I found A, I can use the formula V is equal to U plus AT, which is the derivation of this formula itself. And I get the answer of V as 16 meters per second. Change in momentum, that is delta P, that is P2 minus P1, is mass into change in velocity. Here, of course, mass is constant, so the change happens only in the velocity. So we know all the values. Change in velocity means V minus U. The answer is 48 kilogram meters per second. This is the unit for momentum, by the way. Now the 10th question. A motorbike of mass 100 kg moving at a velocity of 60 kilometers per hour will have to convert it to meters per second by multiplying by 5 upon 18. And the time is given. It is stopped. That means final velocity V is equal to 0. Find the force. So after converting it into meters per second, that is the SI unit, I use the formula F is equal to ma. But A is not given. But we can find A by using the formula V minus U upon T. So by substituting, I'm getting the answer as 166.7 Newton. Now the 13th sum. A force of 20 Newton acting on a mass m1 produces an acceleration of 2 meters per second squared. Force is given, acceleration is given, I can find the value of m1. Similarly, in the second case, same force. So again, force is 20 Newton, but this time acceleration is 4 meters per second squared. So using F is equal to ma, I can find the value of m2. So after finding m1 and m2, I will add them because they have mentioned that they are tied together. What will be the acceleration? That's what we have to find out. If the same force acts on them, so the force is again 20 Newton. So case 1, I found the value of m1 and I found the value of m2. The total is 15 kg. Force is same 20 Newton. So the new acceleration, overall acceleration is 1.33 meters per second squared. 15 sum. A bullet of mass 30 gram converted to kg fired from a gun at a velocity of 80 meters per second. So that's the initial velocity. It strikes and comes to rest, means final velocity V is equal to 0. It penetrates a distance of 4 centimeters converted to meters. Now let's find the initial momentum and final momentum. Initial momentum, that is P1, is m into initial velocity. That comes up to 2.4 kilogram meter per second. Final momentum is m into final velocity. Well, final velocity was 0, so final momentum is also 0. C, they want to find the velocity. They want to find the acceleration. We know the value of V, U and S. So using this formula, this kinematic equation, we can find the value of acceleration. We can't use V minus U upon T because T is not given. Clearly, we'll get a negative answer because this was a case of retardation. The answer is minus 80,000 meters per second squared. But when we write retardation, we don't put the minus sign, 80,000 meters per second squared. And finally, they want the force. We get a negative answer, but we should always end with a positive answer. And in brackets, write retarding. 15 sum. A bullet of, that was done. 17 sum. 2 spring balances are attached to each other. If one of them is reading 20 Newton when pulled, what will the reading be on the other balance? Well, third law, to every action there is equal and opposite reaction. So the other spring balance will also show 20 Newton but in the opposite direction. Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.